My name is Brian Cunningham. I'm with ELPRO Technologies, and today's webinar is going to be covering basic configuration and setup of the 245U-E and the 945U-E Ethernet radios. Okay, so to get started, one of the first things I like to discuss is where these products fall in the ELPRO Technologies portfolio of products. These are going to be our Ethernet pass-through modems. So on the third row of devices, these are the radios that we are going to be referring to today. Essentially, all of these radios here, whatever you put into the Ethernet port of one radio comes out the Ethernet port of the opposite radio. So they do not manipulate or change the data in any format. It's whatever goes in one radio comes out the other radio. Now, the series of radios we're going to be talking about today, these are our high-speed Ethernet modems. These are the most popular devices. They're capable of doing up to 54 megabits per second of throughput over the air, and that's plenty of throughput for PLC applications, for video camera applications, or even linking up two company networks together. So it's going to be this series of radios that we're dealing with right here. Now, the main difference between the two is the 945 is a 900 megahertz radio, whereas the 245 is either a 2.4 gigahertz radio or a 5.8 gigahertz radio. The throughput will be the same on all of these radios at 54 megabits per second. Okay, now the distance that you can accomplish with these radios is quite different, and this is because of the frequency. Generally, the lower the frequency, the greater the distance. So just in generic terms, the maximum range we would expect to get with our 945U-E is approximately 9 miles. The maximum distance with the 2.4 gigahertz 245U-E-G1 is approximately 6 miles. And with the 5.8 gigahertz version of that same radio, approximately 3 miles would be the maximum distance. Now, of course, you can go further if you use super high gain antennas, and lots of our customers have done so, but those numbers that I just quoted are generally typical maximums that we can expect in real world conditions. Okay, so now that we've covered the products that we're going to be discussing, the next is to talk about the type of network that we will be setting up. In today's example, we're going to be setting up a simple bridging network here. And essentially what that is going to enable us to do is to just connect this computer to this programmable logic controller, all on the same Ethernet network together. And what this will enable the computer to do is to talk to the PLC as though we had an Ethernet cable strung this entire distance directly into the Ethernet port of that PLC. But instead, what we do is we take an Ethernet cable from the PLC, we wire that into the Ethernet port of the radio, and we do the same on the opposite end. We wire an Ethernet cable from the radio into the computer, and now we can link these two devices together. Now, in this example, we're setting up a bridge network as opposed to a router network. And the only difference is a bridge network, everything is on the same subnet. So the PLC is 192.168.0.10, and everything else is on the same subnet. So this is .6. Over here, the radio's .1, and the computer is .5. So everything has the same prefix, the same 192.168.0, and then the third portion, the fourth portion of the subnet is different for each device connected together. Okay, so then once we've figured out what sort of network we're going to set up, the next part is to log into the radio. Now, if the radio is has been used by a customer, or somebody has adjusted some of the parameters on it, we may not know what the IP address of the radio is, and therefore we will want to set this dip switch here to the setup position. And when that dip switch is moved from the run position that you can see it is in this photograph to the setup position, then we can log into the radio using the setup IP address that is printed on the back label of the radio. It's referred to as setup mode IP, and in this particular radio, it's 192.168.0.135. So all I have to do is set the dip switch to the setup position, then cycle power on the radio, and when it boots up, it will have this IP address on the rear label. Now keep in mind that in setup mode, the radio module is not powered on. So the radios will not be able to link up over the air when a radio is in setup mode. It must be in run mode to be fully functional. Now, if we go ahead and change the IP address of this radio to something different, that will be reflected when we have the radio back in run mode. So in run mode, it uses the IP address that the user has set inside the radio. In setup mode, it uses the IP address that is printed on the rear label. So this is your back door to get into the radio if you forgot what the IP address you originally assigned to the radio is. Okay. So once you apply power to the radio and you connect your Ethernet cable to the radio, and the other end of the Ethernet cable is plugged into a computer, but you should see the OK LED go solid green after the 60-second boot up period. Then the next thing you should see is this LAN LED go solid orange. And of course, it has to be plugged into a computer, and the computer has to be powered on for the LAN LED to be solid orange. At the same time, you should see these two LEDs on the Ethernet port of the radio itself. One is yellow, the other is green. Those are the same Ethernet ports, they're the same LEDs that are on every Ethernet port of most computers, and that just tells you that the radio connected to the computer or to the PLC or to whatever external device. So before we can log into the radio, the OK LED must be solid green. The LAN LED must be either solid or flashing yellow. Okay. Now the TX link LED, in this picture, you can see it quite vividly here. It could be on solid green, indicating a radio link, or it could be flashing if it is set as an access point, or if it is polling remote radio, or it could be off if it's set as a client radio and there is no activity between the two radios. So the status of the link LED is not really important to us here. And in this photograph, these bottom LEDs are off. However, it seems to be the flash or the lighting gives the illusion in this photograph that these LEDs are on. These LEDs are in fact off. So the RX LED, the RS-232, the RS-45, and the DIO LED, these are all off on this radio at the moment here. It's much clearer in real life. I think it might be the flash of the camera that I took this photograph with may be the reason why these appear to be on. The important thing, OK LED has to be solid green, LAN LED has to be orange before we're able to communicate with the radio. Okay, so then one of the next things we need to do is we need to make sure that the laptop that you're communicating with, that you're going to program the radio with, that its IP address is set to the same subnet as the radio IP address. So how we do so, we go into the settings of the computer, we click on network and internet, then we go to, oops, looks like my circle's a little bit off here. Then we go to change adapter options down here. Sorry, this blue circle looks like it should be directly over change adapter options. And Then we'll come up with our network connections, and we might have a couple of different network connections here. So what we have to do is we have to identify which one. Now it'll be pretty obvious. It's not the Wi-Fi port, and it's not the Bluetooth connection. It's going to be one of the connections labeled Ethernet. A simple way of figuring out which one it is to just unplug and replug the Ethernet cable into the radio's RS-45 jack. When it's unplugged, you'll see a red X. When it's plugged in, you'll see that red X go away. Okay, that makes you, that verifies which Ethernet port we're dealing with. Then what we do, we double click on this icon right here. Okay, then we'll come up with this menu right here. We scroll down until we see Internet Protocol version 4. We double click on this, or we simply click on Properties. Then it will come up with the next menu over here, shows you your current status. In this case, it says we've been connected for 1 minute and 59 seconds. And then we click on Properties. Once we do so, we come up with this menu right here. Most of the time, you'll have your computer set to obtain an IP address automatically, which is what you would normally do when you plug your Ethernet cable into a wireless router to access the internet. In our case, we want to use a fixed IP address. So we click on Use the following IP address, and I know my radios are set to the 192.168.0 subnet, so I'm just going to pick another number that none of the devices or none of the radios are set to, so that everything has a unique IP address. So computer, PLC, both radios, everything has a different IP address here. Then we just click our mouse in the subnet mask. This will automatically be filled in, and hit OK, and we're good to go. Or the other option is you can click on Advanced, and then you come up with this option here, and you can create a rule. So we click on Add, and then we can add an additional IP address. And now we can communicate with equipment on this subnet as well as this subnet right here without having to change all of this in your computer. So this is just a little shortcut here, so you don't have to change your IP addresses on your computer back and forth all the time. As you know, if you're in the business and you're programming PLCs and radios all the time, you're going to have all kinds of different. You're going to be jumping through this menu all the time here. Okay. Now, once we have finished setting up the computer, then we go ahead and we type in the IP address in the browser here the IP address of the radio in the browser here. So now what will happen is it will give you this security certificate warning here. And this is because we don't have our certificates registered. Well, some of the products don't have the certificates registered. So Firefox doesn't know who ELPRO Technologies is. So they give you this, this warning here. What we do is we just click on Advanced. It will give you a second warning here. You have to scroll down in your screen, and then you click on Accept the Risk and Continue. Once that occurs, you will see the username and password prompt pop up. Now, what I'm going to do right now is I'm going to go to my browser, and I'm going to show you exactly how this is done, and I'm going to do this live. So I have two radios right here, and I'm going to go ahead and type in the IP address of the radio I have plugged my Ethernet cable into. So it's 192.168.0.162. Okay. I go ahead and hit, oh, I see, sorry. We did not see those warnings pop up because I have logged into this same radio earlier today. So my computer already knows that I've acknowledged the risk and I've gone through those warning screens. So the user and password prompt just pops up right away. Okay. Then this pops up the home page for this radio. Now it just tells me this is the dip switch setting. I've got it in run mode as opposed to setup. And tells me the MAC address of the Ethernet, the wireless port. This is some basic information that you can type in to help a customer months or years from now if they want to know who installed it or who they should talk to if they have questions about it. This tells you the model of the radio, the country code that we are dealing with. This is the serial number of the radio. And then we have the firmware version, version 2.27 inside this radio. So some basic information in the radio there. So what we want to do to quickly link up these two radios, we want to go to the quick start page. And then we can set this radio's operating mode, the IP address, and all that sort of thing. As a rule of thumb, there are only 4 parameters that you need to adjust to get 2 radios to link up quickly. One is the operating mode. You need to have one radio as the access point, and all other radios must be client radios. So I'm going to go ahead and make this radio the access point. And keep in mind, if it is just a point-to-point radio network with 2 radios, it doesn't matter which radio is the access point or which radio is the client. You could have the access point connected to a remote PLC at a remote site, and you could have the client radio connected to your DCS at the master site. It does not matter which order if it's only 2 radios. Okay. Then we have the IP address. I'm going to leave this with our factory default. Then we have the SSID. Now this is just like if you take your computer into a coffee shop and you log into the local Wi-Fi. You know, it'll say Starbucks coffee. This is the same thing that you would see over the air. So in this case, I'll just change it to something really simple. Just change it to test. And then the next is the radio encryption. We have 3 different levels of encryption here. AES, the WPA2-PSK AES is the most advanced encryption. And I'm going to leave the, well, maybe I'll change that password. I'll set it to something a little different here. We'll set it to the word test. And that's it. Those are the 4 parameters. So it's the operating mode, the IP address, the SSID, and then lastly, the encryption. And once we've set all these parameters, we're good to go. Okay. Now, we have 2 buttons down at the bottom here. We have Save Changes. Now, what this does is this saves all changes that I've made on this page, and it allows me to go to another page and make additional changes. If I just go ahead and click on a second page without saving the changes, all the changes I made on this page will be discarded. So for now, I don't need to go to any of the other pages. So I'm just going to go ahead and hit Save Changes and Reset, and this will reboot this radio. Oh, here we go. It's telling me I have to enter in a longer password. Okay. So we'll just type test and test. Yeah. Then we'll go ahead and hit Save Changes and Reset. And now this radio is beginning its reboot process. Now what I'm going to do is I'm going to take my Ethernet cable, remove it from one radio, and plug into the second radio. Okay, now I'm going to open up a second tab here, and we'll type in the IP address of this second radio. Okay. And again, I have logged into this radio earlier this morning, so my computer knows that I've already bypassed and acknowledged the security warnings. I can just go ahead and hit acknowledge the password, and up it prompts with the home page of the second radio. Okay, then I head over to Quick Start. And here, we just remember we need to set those 4 parameters. The opposite radio is the access point, so we're going to leave this one as the client. We're going to leave the IP address to the factory default of .135. We're going to change our SSID to match the other radio. Okay. And then we're going to set our radio encryption to match the other radio. Okay. And here we go. So all of this should match the opposite radio. And we just hit Save Changes and Reset. So now the second radio is rebooting. And in 60 seconds or so, it will go ahead. It should link up with the opposite radio. Now, this countdown timer is just an approximate timer. It just estimates the amount of time required to reboot the radio. So I can disconnect my Ethernet cable. The Ethernet cable does not need to be plugged into the radio while it reboots. It just takes all that information, goes ahead and reboots, and once it's finished, then it'll be able to communicate on Ethernet port. Okay, so I can head back to radio number 1, and we'll go ahead and hit continue. And it will pop up with the home page for this radio. Okay, now I can see on from viewing the LEDs on the two radios that they are now both fully booted, and they both have a solid green TX Link LED. Now, as I mentioned earlier, the TX Link LED is a dual purpose LED. It will flash red when TXing or transmitting, and it will go solid green when it has a radio link. So normally it'll be solid green most of the time, flickering red when it is transmitting. Now, to verify that I have the connection between these two radios, I would go to the connectivity screen here. And I click on connectivity. And it will show me what the RSSI, the received signal strength indication, is to the opposite radio. Now, there's a number of pieces of information that are all shown here. This is the MAC address of the opposite radio. This is the IP address of the opposite radio. This is an identification of all of the clients that are connected to this access point. It will just be a number. It starts at 1 and simply counts up. So if I had 10 clients connected, they would all have numbers 1, 2, 3 going all the way up to 10. The channel, this tells me which frequency channel I have set the radio to. The rate, this is the over-the-air data rate that this radio is using, and this represents 3 megabits per second. Okay. Then we have the RSSI, the received signal strength, a value of -60. So that's an ideal setting. And then we have our BGND, which stands for background noise. A background noise of -98 indicates we do not have much interference at all. What is important is the difference between these two numbers. We need to have a minimum of 10 dB difference between the RSSI and the background noise for effective communications. And in this case, we have close to 40 dB difference between these two. The CAPS, this is short for capabilities, and this refers to 802.11 capabilities, just some of the different protocols in the radio. This information is not particularly useful for troubleshooting or for our purposes. Okay, now we've seen that we have -60 RSSI on one radio. Let's go to the other radio and see what its connectivity is like. Okay, So what we do is we go to our second radio. Now I am connected over the air. I'm not directly, I am plugged into number 135, but the information we're viewing from radio number .162, that was all over the air. Okay, so now we can see this radio here. RSSI values generally should be the same between the master radio and the remote radio, or the access point and the client radio. They should be the same, or plus or minus 3 dB. So there could be a 6 dB spread if one radio was measuring a touch high and the other radio is measuring a touch low. The background noise is relative to where the antenna of this particular radio is located. And again, since they're both in the same room, the background noise levels are going to be similar. Now, radio 135 is a client radio, and therefore it will show you a list of all access point radios that it can see. So this is the site survey. These are all the access point radios that it can see. And of course, there's just one because I have no other radios powered up in this room. Now, I should mention that the 245 radio would be very, very similar to the 945. In fact, they even use the same firmware. They are so similar. All of the menus will be virtually identical from one to the other. The only differences will be in, say, the radio page. You'll see 2.4 gigahertz frequencies referenced instead of 900 megahertz frequencies. Now, one other thing that we can do to test the throughput is we can go to our command prompt and we can do a ping test. Okay, now I am directly plugged into, whoops, I see the mistake. Let's I've entered in 169 instead of 168. So of course this message will time out. And here we go. I'll just go ahead and fix that error. 168. Okay. .135. Okay. Now you can see it's extremely fast. These are pretty high-speed radios. In fact, I'm going to do a comparison, and I'm going to compare it to the opposite radio, which will be done over the air. Okay. So let's have a look here. It looks like currently I'm plugged into 135. So this is just pinging the radio that I'm directly plugged into. So there is no over-the-air transmissions. So you can see the throughput is pretty fast and fairly consistent. Going over the air, of course, it can take quite a bit longer. The radio may have to do retries if it encounters interference or multipathing or something else. Very, very common. Almost all radios are set up to do retries automatically because these are normal occurrences in any RF environment. So in this case, we're still seeing some very fast throughputs. The average was only 8 milliseconds. So again, a wireless link showing an average of 8 milliseconds for pings, a hardwired link showing 3 milliseconds for pings. So you can see these are very high-speed radios. So we've just verified that these radios are linked up and that we can ping between the two devices. Now, I'm going to show you one extra thing that we like to do, and that is we're going to go to the radio page. Whoops, let's head over to our access point radio, and we'll head over to the radio tab, and we'll have a look at what frequency channel we're set to. Now we're set to channel 15, which is centered at 907 megahertz, and it is 2.5 megahertz wide. With a 2.5 megahertz wide channel, the maximum throughput we would typically expect is going to be about 3 megabits per second. Okay? Now we've left all these other parameters at their factory default. We've left the transmit power at 28 dBm, which is the same thing as 630 milliwatts. However, I have two whip antennas connected to these radios with two 20 dB attenuators in series. So each antenna has a 20 dB attenuator in series. So what that means is that when I add that attenuation together, it's 40 dB of attenuation. So this RSSI number, if I were to disconnect those attenuators, it would be 40 dB stronger. So instead of negative 64, I would have a value of negative 24. Now these radios will begin saturating at a value of approximately negative 40. So therefore, I inserted the attenuators to get our RSSI into our sweet spot of between negative 40 and negative 70. Now the radios will work beyond that range. They'll work all the way down to about minus 10 or minus 20, but the radio will be saturated because the signal is so strong and the throughput will be lower. Similarly, we can have these radios operating at negative 80 or even all the way up to negative 90. However, the radio signal is very weak at that point. The radio will have to do lots of retries. It will have to insert lots of forward error correction, and therefore the throughput will be much lower. So our ideal RSSI is between negative 40 and negative 70, although the radios will work outside of that range. Okay. Now what I can do is I can head back to my radio tab here. And I'm going to go to the advanced radio configuration here. What I'm going to do is I'm going to enable the iPerf server so that we can do a throughput test and see how many megabits per second we can get through on this radio. Okay. Now I've enabled the iPerf server on this radio 162. So I'm going to go to the second radio and I'm going to go to the throughput test, and I'm going to type in the IP address of the first radio. Okay. So I head over here, I type in 192.168.0.162. Okay. And we just have to wait another few seconds for that radio to finish booting up. And then when it does, we will look for the green TX link LEDs to be solid. And once they are, we can commence the throughput test. Okay. I see just now the radio has finished booting up. I have a solid green link LED. And I'm going to go ahead and hit measure throughput. Now, observing the radios, you should see the TX link as well as the RX LEDs flicker rapidly as the iPerf test jams as much data as it can through the radio pair. In this case, it did a throughput test for a 10-second interval, and we were able to get throughput of 2.23 megabits per second. Now you can see the throughput is not entirely consistent. It does go up, it does go down. These are generally going to be caused by either interference or multipath conditions. Those conditions went away for this period of time, and the throughput was able to increase all the way up to about 3 megabits per second. So let's just try that one more time and just see if we can repeat those results or possibly improve it. Normally, I would do this throughput test about 3 or 4 times to get a better average. Oh, here we go. It seems to be pretty consistent here. 2.29 or roughly 2.3 megabits per second, and this is actual user data. that we are able to get through. Now, if I had set my radio to a wider frequency channel, I should be able to get much higher throughput. So we have a 5 megahertz wide channel. We have several of them here. On the 5 megahertz wide channels, you should be able to get about 6 megabits per second of throughput, of user data throughput. With the 10 megahertz channels, that's generally doubled to about 12 megabits per second or thereabouts. And we do have a 20 megahertz wide channel, and you should be able to get even higher throughput with this channel, but generally, because of the clear channel assessment, whereby these radios listen to see if anybody else is transmitting anywhere across your bandwidth that you're using, we don't see the performance generally work as well in a typical industrial environment as we do with the narrower frequency channels. And this is because if I set it to a narrower frequency channel, it is only doing its clear channel assessment across 1.25 megahertz of bandwidth, instead of looking to see if a full 20 megahertz has no interference anywhere on it. So it can be a trade-off, and you may have to do some testing in your unique environment. My experience has been the 2.5, the 5 megahertz, and the 1.25 megahertz channels generally seem to work best. Okay, so that pretty much covers what I wanted to talk about today, which is basic setup and networking of two radios, the 945 and the 245 radios. Again, they're virtually identical. From a factory default, all we have to do is just change 4 parameters. Now, if you have played with your radio a fair bit, you can go to System Tools and do a factory default configuration reset. This will restore the radio back to its factory parameters and is an excellent starting point because, as you can see, there are dozens of different parameters that we could have adjusted that may impact whether these radios will link, their performance, their throughput, numerous different parameters. So that is it for today's session here. And let's just see if anybody has any questions here. Next week's session, in 2 weeks' time, we will be showing advanced configuration of the 245 and 945 radios. So that will be carrying on from today's session, and it will be showing you troubleshooting, diagnostics, and how to set the radios up for optimal performance for maximum throughput in each individual environment.